Hello, so today we are going to do this weekly daily challenge, Leetcode daily challenge, number of students enabled to eat lunch. So essentially we have a queue, you can think of it, we have a queue of students, and we have sandwiches that are sort of in a stack, right? And the front of the children queue can take the top sandwich if it is the same number. If it's one, if the student number is 1, they can take 1 only. If it's 0, they can take 0, right? But if it's different, like in this case here, then what happens is this student needs to go to the back, and now the front one is this one, and so this one needs to go to the back. So now we have sorry, not the back of the sandwiches, of course, they need to go to the back of their student queue, and then 0 now matches, and so this one takes this sandwich, and then this one now doesn't match, right? And so now we have 1, and so this 0 becomes here, and so 1 takes this one, right? And then it keeps happening until basically all of them take all the sandwiches. Okay, now there may be scenarios where we may have some student left where they can't eat any sandwiches. So let's say, for example, this one has a preference for sandwich 1, then they can, because we only have 2 sandwiches of type 1, and so they can't. So that can happen, and that's exactly what the problem asks us to do, which is return the number of students that are not able to eat. Okay, if you look at the construct, they are very, very small. So how can we do this? Well, the simplest thing is just to simulate the problem, right? Just have 2 queues and just simulate it. Okay, so that means basically I have you can have a double queue, or you can even just use a list, and to pop from the front of a list you can just do something like pop position 0, right? So as long as we have students and we have sandwiches, let's keep going. We will need here some condition for when it's no longer possible to eat. So we need that. But before that, what's the preference of the student at the front of the student queue? Well, their preference is the first position, which we can pop at position 0. Now, if that position is the same as the top sandwich, then we can just pop the top sandwich because it will be taken by this student. Okay, so we can pop at the same time from position 0. Otherwise, when they are different, what happens here? Well, when they are different, we said the student goes back to the end of the queue, so we need to add them to the end of student. So, and then we append it like okay. Okay, so what's the condition to be able to determine that it's no longer possible to eat? Well, let's say, for example, the sandwiches we have, maybe one is on at the top here, and we have some other number, right? Now let's say the preference of all students is, for example, 0, right? Now we have a problem, right? Because there is no student that has this as preference, so we won't be able, even if we had, let's say, other 3 these zeros here, right? We won't be able to get to them because we are stuck here. We can't remove this sandwich, right? So basically what this means is anytime we have the top sandwich is not a preference for any student, then we are stuck, right? That's the only case in which we are stuck. You can think about it a little bit, try more examples. But now that we are stuck, what should we do? Well, then in that case, all 4 students won't be able to eat, so we just return them. So that's exactly what we're going to do here. Now, what is the condition? Well, if the top sandwich is not a preference for any student, so it's not in students, then all of the remaining students won't be able to eat, and so we can just return the length. Okay, and then here, of course, when we are done, we return the length of the students, number of remaining students. Okay, now here we check the top only if sandwiches is not empty, right? And now if we run this, submit, it gets accepted. But if you look at this is open, right? This while loop itself, but within the while loop we are checking for contains here, which is also open. So you can think of this solution as an open squared time solution. So we need to make a better than open squared. How can we do that? Well, the key thing to note or to think about here is that let's first just do a couple of things here. If you have, let's say, preference is 4 ones, maybe 3 ones and then 1 0, but the sandwiches are 3 zeros and then 1 1. Okay. Now, at most, the number of students who is going to be able to eat, which let's say in this case is going to be 1. Right? But if they are, if it's 1, right? Because the other one, it's 2 at most, right? These 2, right? And then the other 2 won't be able to eat. Okay. So how do we do this? So already this tells you that the number of ones and the number of zeros is important. Okay. So what we can do is just calculate the number of zeros that students prefer and the number of ones the students prefer. Okay. And each time we find a sandwich of zeros, that means a student will end up taking it. They will just, let's say if it's 1, then this one will be able to take it easily. But let's say this is 0, okay? Now this 0, it's not a problem. It will end up getting to this 0 because it will move here. And then this one will take this one. Now let's assume we have 1 here. This one will take this one. And eventually this 0 will get to the 0, right? And so we don't really need to worry a lot about the order of the students, right? And so what we can do is first just count how many zeros students prefer, how many students prefer 0, and then how many students prefer 1s. And we can just go through the sandwiches we have, right? Like this. And now if it's a 1, then we have, if the sandwich value is 1, then one of the students that has a preference of 1 can take it. Now they may not take it immediately. They may have to go back to the back of the queue and end up taking it. But as long as there are still 1s available, they should be able to take that sandwich. As long as there are students who prefer this sandwich, they should be able to take it. And so we do 1. Now we do the order of sandwiches because of what we mentioned in the previous solution, which is if there is a sandwich value that blocks, let's say of 1 that blocks zeros, then we are stuck and we need to just return the number of we just need to return the number of remaining students, right? And so that's why the order we are going through the sandwiches here. Now similarly here we do the same thing, but if it's equal to 0, of course. And here we want to check zeros. As long as still we have some students that prefer zeros, they take this 1. One of them takes this 1. And then now, if this happens, that means we found a sandwich with value 1, but there is no student that has a preference of 1 remaining. And that's a problem. That's a similar problem to what we had in the previous solution. Or if we are here and it's equal to 0, but the number of students that prefer 0 is now equal to 0, then that means there is no remaining student that prefers 0. And so we are stuck again if this is not happening. So if both of these are not happening, we are stuck. And so we, in that case, want to return the remaining students. What are the remaining students? Well, we know we are at position I. Okay, so that means from I minus 1 to 0, those students were able to eat. And so what's the number? What's the count of that? That's just I. And so we want to return the remaining ones. So the remaining ones is just the number of students minus the ones that already ate. The ones that already ate, the number is just I. Okay, so this is just going to be the length of actually sandwiches, because we are going through the remaining sandwiches. The remaining sandwiches is the same as the remaining students. So we can also just do ones plus zeros, remaining ones plus zeros, but I'll just do it this way instead. And then we can return 0 at the end, because that means all of these were fine. We never got a case where a sandwich has no student that can eat it, and so we were never stuck. So all of them were able to eat. Now if we run this, we can remove this and submit. Okay, there is one slight problem here. Let's see what's happening. Yeah, sorry, this is it, the number of ones. Okay, let's submit, and this gets accepted. Now in terms of time complexity, this is better because this is just oven time, and we are not really using any extra space, so of one space. Now even each of these ones is just oven, so overall it's oven time of one space, so a lot better in terms of complexity. Yeah, so that's pretty much it. Thanks for watching, and see you in the next one. Bye.